the domain. So again, you're only focusing on what's under the square root. That's just this part. Only this part. Because it's under a square root, your domain, x minus 5 has to be greater than or equal to 0, which means x has to be greater than or equal to 5. So in interval notation, my domain would be 5 to infinity. So what I like to do is whenever it's a square root, I always start with my vertex. Which is 5. And we have to pick numbers that are greater than 5. Now, you can pick any number you want, but I like to pick numbers that I know will give me a perfect square. So any ideas what other numbers I would use? So if I put well, I can't use 4 because 4 is less than 5. So if I use a 9, yeah, because 9 minus 5 is 4, so I could use 9. I could also use 6. And then my grid is kind of small. So we're going to just, that's enough. We'll just use those 3. All right, so, okay. All right, let's do it the right way, sorry. Okay, so what would be the next one then? 9. Okay, so the next one would be what? 4, 9. So I would have to do 14. Because 14 minus 5 would give you 9. So there we go. All right, so now let's go ahead and type that in our calculators. So you're going to have a negative, and I shouldn't have said type that in your calculator because you really don't need a calculator for this. That's a habit that I say that, but you shouldn't need one. So when I put my first one, 5, 6, 9, and 14, I know that this is going to give me 0. What's the square root of 0? 0. And then there is no such thing as a negative 0. 0 plus 1 is 1. So that's my vertex. I'm going to start off at 5, 1. And then for my next one, this is 1. The square root of 1 is 1. Then you have negative 1 plus 1, which is 0. And for the next one, we have a 4. The square root of 4 is 2. And then negative 2 plus 1 would be negative 2 plus 1 would be negative 1. And then 14 minus 5 is 9. The square root of 9 is 3. Negative 3 plus 1 is negative 2. So let's go ahead and plot these 4 points. So I have 5, 1. And then 6, 0. And then 9, negative 1. And then my grid is small. It doesn't really have enough space. So I'm just going to trying to make a nice graph. It's kind of hard. Okay. So that's a good little sketch of what my graph will look like. So this is my domain. And what do you think my range is going to be? That's a little tricky. What'd you say? Not 5.
Oh, I'm stupid, sorry.
You're not stupid. We don't say that. Negative infinity to 1. So my range would be negative infinity to 1, because notice that my y values are getting smaller. So they're starting at 1 and getting less than 1. So it's less, y is less than or equal to 1. So that would be my range. Okay, so now let's talk about piecewise graphs. Come back to that. All right, so let's go ahead and copy this down. We call this piecewise graphs because you're graphing two functions on one coordinate plane. So I'll give you a minute to copy it down, and then we will talk about it. So if you watched the video from Friday, it was just some introduction to piecewise graphs, and now we're going to actually graph it ourselves. Before I forget, I got a couple of announcements. Homework 9 is due Thursday. I don't think I updated it on Canvas. You have a skills check. We'll do it Thursday. We'll do our skills check Thursday. It's everything except for piecewise. So what I will tell you is that you will have to graph on the skills check either a quadratic, an absolute value, a square root, or a cubic. So one of those is on the skills check. And since the first one was bad for a lot of y'all, you want to make sure this one is good so we can do better than we did on the other one. A few people got 100, so we ain't worried about it, but we need to lock in for that one. Okay? All right, so let's go. I got two functions. Let's start off with the red function. This one says y equals 2x plus 1. But there is a condition. This is only true when x is greater than or equal to 1. So I'm going to make my table. I'm going to start with 1. And then I'm going to pick some points greater than 1. So give me some numbers you want to use. 2, 3. Okay, let's do 2 and 3. So go ahead, pick up your calculators and figure out what these numbers would be when you use this function. If we input a 1, 2, and 3 into that function, what would be my y values? So I'll give you a minute to figure out what they would be. Now, when you're doing this on your own, you can pick whatever you want to pick. It just has to follow the rule, which says x has to be greater than or equal to 1. So could I use 0? No. It only can be greater than or equal to 1. Okay. What do we get for the first one? What is 2 times 1 plus 1? 3. 2 times 2 plus 1. 2 times 3 plus 1. All right, let's go ahead and graph these points. So I have a point at 1, 3. Let me go ahead and freeze this so that. Okay. So I have a point at 1, 3. And then I have a point at 2, 5. and a point at 3, 7. Now in geometry, we call this a ray because it's only going in one direction, okay? So this is what you don't do. You don't do this. This is wrong. Why is that wrong? It's only greater than or equal to 1. So you're going to start your line at the 1 and it's only going towards the right. And that's that piece. So you're not graphing the whole equation. You're only graphing a piece of y equals 2x plus 1. So now let's do our second function, which is our green function. Y equals the absolute value of x. So the rule says that x has to be less than 1. Now, even though it says it cannot equal 1, we still have to start our table with 1. I'm going to start it with 1, but it's going to be an open point. That first point only is open. And now let's pick some numbers less than 1. So I'm going to use 0, -1, -2. There really isn't a rule to how many points you need. It just has to be enough to show what the graph should look like. So what is the absolute value of these 4 numbers? The absolute value, because that's what it says. It says take the absolute value of the input. So what's the absolute value of 1, 0, -1, and -2? So the absolute value of 1 is 1. The absolute value of 0 is 0. What about the absolute value of -1? And the absolute value of -2? All right, so now let's go ahead and graph it. Again, I'm starting with an open circle at 1, 1. If I close it, it's no longer a function.
Because it's got the same x.
Right. So we got to make sure one of those points should be open. And then this one should look like the letter V. And it should be pointed. And that's my piecewise. You do not have to state domain or range for a piecewise graph. Yes.
Does it matter which one is open or closed?
It does. How did I know that the green function had to be open and not the red? Because of the inequality.
Yeah.
What's the difference between these two inequalities? Which one is equal, the red or the green? The red. Yes, that does matter. That is a very good observation. Any question? All right, next, let's go. Let's go ahead, copy down this one. 2 piecewise functions. This time the break happens at 2. All right, so for my first one, the red function, again, I'm going to start this at 2. And then what does that inequality tell us to do? Use numbers less than or greater than 2. So I'm going to use 1, 0. I think that should be enough. Go ahead and type that in your calculators. Now, when I do this first point, is it open or closed according to the rule? So who says it's open, this first point? Who says it's closed? Who's not sure? All right, if it's equal to, it's closed. If it's not equal, it's open. This is not equal. It doesn't have a line under it. So that one we start off open. All right, so let's go ahead and figure out what we get. We got 2 minus 2 squared, which is 0. We have 1 minus 2 squared, which is 1. We have 0 minus 2 squared, which is 4. Let's go ahead and graph that. So this is just half of a parabola. So 2, 0. 1, 1. And 0, 4. Like so.
Wait, so for these ones, do we need 4 points or not?
It's really, so like I know this is a parabola and I know that it's half of the parabola. So you really, there is no minimum.
Okay.
You have to understand what kind of function it is and where your vertex is. You kind of have to look at it. Like I should be able to tell that that's half of a parabola.
So for these ones only, these are like half of the parabola, so we don't really need.
It's a piece. That's why it's called piecewise, because it's a piece of the graph
Okay.
instead of the whole graph. All right, so this next one is just y equals -3, which is a horizontal line. This is a constant function. You don't even need to make a table for it, but I will. We're going to start at 2. And then the second one says it's greater than or equal to 2. So let's use 3 and let's use 10. I just pick some numbers. And your y value is always going to be -3. It's constant. Now this first point starts closed because of the inequality. So I'm going to draw this out. I'm going to put a closed point at 2, -3. And you're really, you don't have to necessarily plot points. It's just a horizontal line going to the right. And that would be your graph. This is what we would call one of the more basic piecewise because there's only 2. Now, when you take your test, though, it's going to be a lot more complicated. So now let's do one that you're going to have to do on the test next week where you have 3 pieces because we're not going to give you a 2-piece. It's going to be at least a 3. Well, it's not going to be more than 3. It'll be 3. All right, go ahead and copy this one down. And then we'll work through it together. So we got 3 graphs. And then we'll end here. Tomorrow I'm going to do one of the homework questions. I can't remember which one, but it's one of the homework questions we're going to do together. I'll have to look at it. Let me see. We're going to do number 29. And 35 tomorrow. Yeah, is that right? Okay, I looked here. I gotta look it up.
We have 38 though.
Is it 38? Is it 3 pieces?
We do 7 through 18.
No, it's the other part. You know how it's 2 pieces? It's the ones on page 94. This one.
Oh, this is the notes that we did.
Okay. So like when you go to Canvas, there should be 2 different page numbers.
Okay.
So yeah, pull it up. I'll show you.
said this is the last one?
Yeah, for today.
Okay.
So we're gonna start off with y equals x plus 1. And this tells us to start at -3 and then pick numbers less than -3.
I see it.
You see it? So we're gonna
Yeah, when I pulled it up.
yeah. We're gonna do
29 and 35.
This is 35, 37, 49. Okay, so numbers less than -3. So could I use 0?
Yeah. No, my bad.
No?
Sorry.
What's some numbers I could use?
Negative
-4
-5.
and -5. Okay, that works. Let's go ahead and plug it in. So take -3 plus 1, -4 plus 1, and -5 plus 1. Now, whenever it's like 3 functions, I do like to draw in to separate. I'm going to actually separate my graph into 3 pieces. This is optional. I'm going to draw in what I like to call a fence. So I'm going to draw in a fence at -3 and a fence at +1 to kind of like divide my graph into pieces. This first graph can only occur right here.
Is that because of the 3 being?
Because this is a part of the graph where x is less than -3.
Okay.
So this piece. So I kind of like to think of it as a yard that's broken into fences. So we got like a fence. So here, this is the first graph. So when we do that first one, we have -3 plus 1, which is -2. And then -3, -4. All right, is this first point open or closed? What do you think, according to this inequality? Who says closed? Who says open? It's closed. All right, so let's go ahead and plot that. I'm going to put a closed point at -3, -2. And then a closed point at -4, -3. And then it just kind of decreases down. And then again, it's only going to the left. You can't go into the other part of the yard. And then we got our next function, which is y equals x squared minus 2. Okay, so the first thing I know this is a parabola, and I know that I need to have -3 and 1. So we have to have a -3, and we also need to have 1. And we need to pick some numbers in between it, though. So I would probably definitely do 0, because 0 is my vertex. My vertex is at 0, -2. So I would definitely use that one. Now go ahead and use your calculators to figure out, well, I gotta quit saying calculators. You don't need a calculator for this. So 3 squared is 9, and 9 minus 2 is 7. 1 squared is 1, and 1 minus 2 is -1. So when we look at this inequality, we're gonna start off open because the -3 is not included, but that +1 is included. So this is closed. Let's go ahead and plot that. So -3, 7. Sorry, I put that in the wrong place. -3, 7.
Wait, it's open.
You right. See, I'm glad you paying attention. Thank you, Jenny. Appreciate you. And then 0, -2. And then a closed circle at 1, -1. That's kind of not enough. I feel like we need one more. Let's go ahead and put another one. Let's put -1 in. You did 5?
Wait, which one are you
I'm doing the blue one. I mean the red one.
But it would have to be a number between -3 and 1, right?
Yeah, I just feel like right here, it looks like it just don't look right to me. So I feel like I want some more points over here.
-2.
You could do -1, you could do -2. So go ahead and fill it in. If you do -1, that should be -1. I feel like that looks a little better. It should. Okay, to me that looks a little bit better. And then we end off with a square root.
Is there not an arrow going, is it because it stops something?
Right. So why didn't I put arrows on my red function?
Because x has to be greater than -3 but less than
Yeah, it's only in between negative. It doesn't go towards infinity. All right, the last one, y is equal to the square root of x minus 1. So I'm going to pick some numbers. I'm going to do 1, 2, 5, and 10 because I want perfect squares.
What is the square root? That's when we have to have 4 points.
What'd you say?
What is the square root? That's when we have to have 4 points.
So there really isn't a minimum for a piecewise. It just has to be enough to look like the shape. So what I mean by that is,
I did 3 points for all my graphs.
okay, probably good. Is this first point going to be open or closed?
Open.
Open. And I'm making my points extra big. Of course, when you're doing it on your test, it doesn't have to be. But if I'm not sure if it's open or closed, then I'll say that it's closed. So just make sure I can tell what you used. And that would be my graph. All right, use this time to continue working through your homework questions. Again, homework is due Thursday, skills check due Thursday, test on Monday.